Good morning. We're going to continue on with using our data structures. We're going to look at the actual implementation of them again. We have predefined a set of strings: Alice, Coffee, Java, Ada, Alan, and Grace. Some strings that we can use to actually store inside a data structure. Today we're looking at the data structure of queue of type string using C++. Our queue is called demo queue. And we have a couple statements we're going to evaluate. Obviously this declares and initializes our data structure right here. We call enqueue passing to Coffee, add passing to Alan. We call dequeue, enqueue Ada, enqueue Alice, peek. We enqueue and pass it Java. We pass remove 0, and then we call add and passing it Grace. So we're going to pass a couple different structures for this, and we'll see what would actually happen. On the idea of our remove and our peek methods, we're going to see, and our dequeue method, well, obviously we'll pretend we're just outing the information since we are obviously on a screen and we don't have anything we can actually show. To help keep track of some information, we have the fact we're going to use some colored markers to keep track of it. We'll use front and end in green to keep track of our front and end pointer. Our previous pointer connections will be shown with purple. Our next pointer connections will be shown in pink. And our size will be shown over here also in black. To keep track of our demo queue over here, we'll keep a reference to the string variable we have as the front and end pointers, as well as keep track of our size, so we can actually see that as we look and see what's going on. And we'll place the actual queue itself over here on the whiteboard, so we can see how that's going to be put together. So, looking at our structure again for our code, our first thing is we create our demo queue, and it's a queue of type string. So when we first declare and initialize our information, that information starts off with both front and end, because the demo queue itself inherits, or the queue inherits from the wlink list abstract base class. Our front, end, and size are all initialized their default data members, which is null pointer for both front and end, and our size value is set to 0 because, of course, when we first create our list, nothing's in it. Fabulous. So now that we've got that basic set of default data members assigned, we want to go ahead and look at what's happening. So our first step is to demo queue.enqueue coffee. Oh, so my queue exists. I have a reference to it somewhere on the heap. I have a variable attached to it that I can use as a programmer. We know what that is. My front and end are both set to null pointer, so I'm going to enqueue coffee. So I'm going to grab my coffee node, okay, turning coffee into code. Fabulous. And I have that. I'm enqueuing that. And so the first step that I do by doing the enqueue is I'm going to set my front pointer to point to this. My end pointer also points to that. So front and end both point to this. Because my default new node pointer that I created right here, my next pointer and my previous pointer are both initialized to set to null pointer. And I update my size and my associated front and end pointer in my data sheet to reflect the appropriate new values. So it's the coffee node. And my size is 1. So I have the appropriate values set up for that. And so I have right here, I have front and end both pointing to this pointer object. It's a bidirectional node of type string pointer. It is a new pointer, so it's allocated on the heap, so I have access to it. Both its previous and its next pointers are both pointing to null right now, because that's what happens when we first create the node. And since it's the beginning node, that's what it's going to be. My next step that I have over here that we're going to execute is demoqueue.add, and we're going to pass it the Alan string. So I grab the Alan string, and I'm going to add that queue, or that node to my queue, so I'm going to bring it up right here. I'm going to make it really easy, and because the queue is very much a linear data structure, we're going to place them in the right order. So first thing I do is I create a new node, and if we look at the code, I have something like add a node or add to queue node, is what we named on that as we look at the previous video for that. So I have a reference to this node right here as a pointer in my code. I also, of course, my reference to my front and end. Now, because this is a queue data structure, the only thing I have to worry about is dealing with my end pointer. So I'm going to go ahead and get my current end, and I'm going to tell it to set its next pointer to point to this new node that we're just adding in. So instead of having that point to null pointer, I'm going to update that. So I'm going to use pink to support my next pointer, and its next pointer is going to point to this new node right here. So that points the end's next pointer to this. I'm going to tell the previous pointer of the node that I just built, I'm going to tell its previous pointer to point to end. Oh, so its previous points to end. So I have a connection right now between both of these, and of course my new pointer by default is node. Its next pointer is automatically set to null pointer. So we have my list right here. My next step after I've made the connections between my pointers is I have to actually move my end pointer. So let's go ahead and reset end to point to the new node that we just created. So this is calling the setEnd method on the list. And so end now points to that new node. So we have a visual connection now. We have this, this, and this. The last step that we have to do is update our size. So size goes up by 1. So we'll go over here and make the appropriate changes on our data. So my end pointer now points to the Allen node. And my size is now 2. So I have a list, front, and end. The front points to this pointer. Its previous is null. Its next pointer points to this one, whose previous pointer points back to this. Nice connection right here. Its next pointer points to null, and it has the end pointer as well. So size of 2. This is the 0 spot. This is the first spot in the node. And again, because it's a queue, I only have access to add to the end and remove from the front. So we have that right there. So let's test that out over here. We're going to test that out with our dequeue call. So we're using demoqueue.dequeue. So when we dequeue, we're going to automatically remove from the front of our queue. So, here's my front. So in order to remove from the front, I have a couple things that we have to do. The first thing we have to do is we have to grab the actual value that's stored in that node. In this case, it's the turning copy in the code. So I grab that and I store it, so I have that information from the string. I retrieve that value. The next thing I want to do is I need to make sure that I move my front to point to front's next. So front is going to be assigned to front's next. So I set front, and I pass this front's second parameter. Okay? So front and end now both point to this node right here. I then have to tell the front's next, the new front, I have to tell it to set its previous pointer to point to null. So I erase this, and I tell its previous pointer to be null pointer, because that is who it's connecting to. Once I've made those pointer adjustments, I then can delete the node that is attached to this. So I delete the node actually out of memory. I then return the string contents of that out of there and adjust the size by 1 before that. So now I have adjusting this. My copy node is no longer in my queue. My front and end are both Allen. And my size is now 1. And so this pointer that was pointing that doesn't even matter, so we can go ahead and just wipe that off right here. So front and end are both at Allen Turing. Allen points to null pointer on both of those because it's the idea right there. Our next step that we have on here is we're demoqueue.enqueue Ada. So we're going to grab my Ada Lovelace node. I'm going to grab that and put it right here. And again, because I'm making a connection between the node that has Ada as the string inside it, so I want to go ahead and I grab end. I tell end that its next pointer is going to point to this new node that I just made. I want to set the new node I just made, I want to set its previous pointer to point to the original end. So its previous pointer points to end. Okay, we've made the connections right there. The next step is to move end to correct the new node. So I take the end and I set end to be end's next, or the new node, whichever one I want to do. I believe in my code I have it set for the new next. So I have that and I point end right here. So I adjust friend and end, they have that now reflection. These are both pointed to that. Of course, my next pointer should be set to null pointer right here. It's automatic by default, but just explicitly to show it here in the video. We then go over here, we adjust our information on our node data so we can keep track of that because we've adjusted front and end on here. So my front is still Allen. My end, however, now is Ada. And my size is 2 again. So we have our node right here. My next step on there is to enqueue Alice. So my Alice node is the string was Brillig. So I'm going to grab the Alice string. I'm going to enqueue it right here. So I create the brand new node. Again, I'm going to grab end. I'm going to tell end to set its next to point to the new node that I just created. So I'm going to grab its next node, which is pink. Yep, pink. I'm going to set, instead of null pointer, we'll set it to pass the reference to the new node we just created as part of the code. So I set next to that. I tell its previous to point to end. So I tell previous to point to end. Right there. I then adjust my end pointer to point to the new node I just created. So I'll erase the end and tell end to point right here. And finally, I adjust my size to grab the original size, 2 plus 1 to 3. So I go over here and make the appropriate adjustments on here. So Allen is the front. The end, I know, is Alice. And my size is 3. My next step is peek. So when I peek, I can see what's at the front without removing it. So I peek at the queue. Oh, look, there's Alan Turing. Oh, okay, it's like I see out Alan Turing. I have no idea of what the pointers are referencing to. All I do is I look at the data that's at the front pointer. In this case, it's Alan Turing. So my next step that we're looking at is demoqueue.enqueue, and I'm passing the Java string. The Java string is a lovely Java class as a string. Fabulous. And I enqueue the Java string. And again, we're keeping the idea that the queue itself is a very linear structure, so we're keeping it all together. And again, the same process applies. When I add or enqueue, I always go to the end. I tell it to set its next pointer to point to the node I just created. So I have a pink line going down here to this, instead of going to null pointer. I then tell its previous of the new node I just made to point back to the node that was end. I then move in to point to the new node that I was at. And of course, my new node's next pointer always points to null. So I now have this information right here. I take my size 3, add 1 to it. My size goes to 4, so I adjust both my end and my front. Notice that when I enqueue, I only adjust the end pointer, and I always adjust the size up. My next line is demoqueue.remove. The only value that will be acceptable on the remove as a parameter is 0 because we're dealing with a queue, so we can only remove from the front. So I go over here, and if I were to pass any other int parameter, my assert statement would fail, causing this entire program to crash, which we don't want it to do. And so I call the remove method. I pass it 0 as a parameter. Oh, so I'm going to grab Alan Turing. So the first thing I want to do is I want to grab the string value that's stored inside this node of type string. This is BiDirectional. So I grab Alan Turing, and I store that information inside a temporary variable. The next thing I need to do is I want to set front to point to the front's next pointer. So I move front over to here. Then I want to make sure that I tell the current front, I want to tell it to set its previous pointer to be null pointer because it's no longer pointing to this. Once I've adjusted that, I then have my variable right here that I've got. I want to deallocate the memory that's attached to that node. I've already retrieved the value out of it. I've already moved front. The next step is to adjust the size down by 1. So I take the get size, which was 4, minus 1 is 3. I then adjust the appropriate pointers on this. So my front now refers to the Ada node, and my size is now 3. My final statement for this is that demoqueue.add passing a grace string. So the grace string is grace hopper. I grab that node, I create it as a new node. I allocate the new memory for that. Again, I then grab end. I tell end to set its next to this new node that I just created. So I grab the next node pointer from this instead of pointing to null pointer. We move it. It points to this new node. We tell this one to tell its previous to point to end. Once I have those pointer chains maintained, then I can move end to point to this new node. And so end is now pointing to this new node. And so we have that chain always happening. And we then want to set our size to go up by 1, so our size is going to go back to 4. So we adjust the end node instead of Java to be Grace. And our size goes back up to 4. And so again, with a queue data structure, we are always only removing from the front of the list and only adding to the end of the list. And so it makes it very easy. The manipulations are always going to happen like that. There's no worry about making interconnections in between this because we only have access to the front and end. We don't traverse the entire structure unless we want to destroy it.